go over how to solve some Hess laws problems. So in this problem, we're being asked to find the change in enthalpy for the given reaction. And we're given this reaction up here, as well as a system of reactions and their associated changes in enthalpy. And essentially what we're trying to do is to manipulate this system, kind of like a system of equations, but it's a system of reactions, so that we essentially only have what's in the parent equation left over and everything else cancels out. So I'm going to start by looking at the first parent equation, number one. I'm sorry, not the first parent equation, the first in the system of equations, which is C2H2 plus 2H2 goes to C2H6. So I'm going to look at my parent equation and see if there's anything here that also appears in this equation. And what I see is C2H2. The problem with that C2H2 is that it is on the wrong side. So what I can do is I can flip it and make it go the other way. So I can write the reverse equation. So I'm going to do that. So I have, instead of what I have there, I'm going to rewrite it as C2H6 goes to C2H2 plus 2H2. Now I'm going to put a box around what I want to keep. So the only thing in this equation that I need is the C2H2, and I need to get everything else to cancel out. Next, I'm going to look at, I don't really see anything in the second one that's going to help me, so I'm going to skip to the third one next, because right off the bat, I see that it has both the C2H6 that I want to get rid of, and it also has the CO2 that I want to keep. Okay, just like before, in the first equation, I can see that the C2H6 is on the wrong side and so is the CO2. So again, I'm going to flip it. So for my third equation, I'm going to flip it and it's going to become 2CO2 reacts with 3H2O. And that forms C2H6 plus 7 halves O2. So now again, I'm going to put a box around what I want to keep, which in this case is the 2CO2. And everything else I'm going to use to cancel out. So I'm going to use my C2H6 is on the left in equation number 1 and on the right on equation number 3. So those can cancel out, and that's all I have right now. So what do I still need? So I have my C2H2 and I have my 2CO2. So I'm looking to get now my 1 H2O and I have 3. And I'm looking to get my 5 halves O2 and I have 7 halves. So now I'm going to turn to the second equation and I'm going to use this to help get the numbers that I have to be the numbers that I want in the parent equation. So I can see that I have 3 H2O on my reactant side, but I only want 1 H2O as I have in the parent equation. So if I could somehow get 2 H2Os on the product side, I could do the 3 minus the 2, which would give me 1 net H2O. So in order to do that, I could both flip the second equation and multiply it by 2, and that would give me the correct number of water. So let's see if that works. So for number 2, I'm going to flip and multiply by 2. So I'm going to have 2H2 plus 2 times 1/2 is 1. So that's going to be 1 oxygen goes to 2 H2O. So right away, I see that I now can cancel out my H2s because I have 2H2 on the reactant side here and 2H2 on the product side here, so those can cancel out. And then I also can turn my 3H2O minus 2H2O gives me a net of 1 H2O, which is what I want. So I'm going to cross those out and I'm going to write 1 net H2O, which I need for my reaction. And I'm going to do the same thing with the oxygens. So for the oxygens, I have 7 halves over here, so I'm going to rewrite this as 2 halves, which is the same as 1. And again, 7 halves minus 2 halves gives me 5 halves of oxygen on the product side. So I'm going to cross out both of those. Again, 7 minus 2 is 5, so that's going to give me 5 halves O2 net on the product side. All right, and let's double check that I have everything. So my 2 CO2, I have 2 CO2, 1 H2O, 1 H2O, 1 C2H2, 1 C2H2, and my 5 halves O2, 5 halves O2. Now everything that I did to the equations, I want to do to their delta H's. So remember what I did was I flipped this, I flipped times 2 this, and I flipped this. So this one becomes positive 94.5. This becomes negative 142.4. And this becomes positive 283. Okay, the last thing I need to do is add all of my delta H's together and round them to the right number of significant figures. And when I do that, what I get is 235 kilojoules.